Greetings and welcome back to EDUC771, Analyzing Educational Research Week 8.
This week we will cover Chapter 13, Quantitative Data Analysis. Week 8 Assignments. Review Week 8 PowerPoint video. Complete Chapter 13 review problems. You do not have to complete a Chapter 13 activity or Week 8 reflection. Remember to submit your research summary number 1 to Blackboard by October the 26th. Continue with your textbook reading assignment. We will cover chapters 9 and 14 in week 9. In chapter 13, we will discuss descriptive and inferential statistics.
Statistics is a set of tools used to organize and analyze data. Employing statistics serves two purposes: description, descriptive statistics, and prediction, inferential statistics. Descriptive statistics describe data that have been collected. Commonly used descriptive statistics include measures of central tendency and measures of spread. A distribution is a graphic representation of data. The line formed by connecting data points is called a frequency distribution. This line may take many shapes. The single most important shape is that of the bell-shaped curve, which characterizes the distribution as normal. The picture in the lower right-hand corner of this slide is considered a normal distribution curve. As a frequency distribution approaches a normal curve, generalizations about the data set from which the distribution was derived can be made with greater certainty. It is important to remember that not all frequency distributions approach a normal curve. Some are skewed. When a frequency distribution is skewed, the characteristics inherent to a normal curve no longer apply. Commonly reported descriptive statistics include measures of central tendency. These are ways of describing the central position of a frequency distribution for a group of data. For example, the mean is the average score within a distribution. The median is the center score in a distribution, and the mode is the most frequent score in a distribution and can summarize variables at the nominal level. In a normal distribution, the mean, median, and mode are all the same value. To practice, compute the following data points. Find the mean by adding the numbers and dividing by the total numbers in the set. Find the mode, the most frequent number. Find the median, ordering the numbers, and then finding the middle value. Rules of thumb for measures of central tendency. Use the mean to describe the middle of a set of data that does not have outliers. An outlier is a data value that is much higher or lower than the other data values in the set. The mean is most affected by outliers. The median is the middle value in the set when the numbers are arranged in order of magnitude. For a set containing an even number of data items, the median is the mean of the two middle data values. Use the median to describe the middle of a set of data that does have an outlier. The mode is the data item that occurs the most times. It is possible for a set of data to have no mode, one mode, or more than one mode. Use the mode when choosing the most popular item. The measure of spread helps us summarize how spread out scores are. The measure of spread may include the range, quartiles, variance, and standard deviation. In this video, I will go into more detail regarding the standard deviation. The standard deviation, represented by the Greek letter sigma, shows how much variation or dispersion from the average exists. A low standard deviation indicates that the data points tend to be very close to the mean, whereas a high standard deviation indicates that the data points are spread out over a large range of values. The empirical rule of a normal distribution states that 68% of the data elements are within one standard deviation of the mean, 95% are within two standard deviations, and 99.7% are within three standard deviations. Notice the darkest part under the distribution curve represents approximately 68%. The darkest blue and the next darker blue portion under the distribution curve represents approximately 95%. And finally, the lightest and other two shades of blue under the distribution curve is approximately 99.7%. With inferential statistics, we can reach conclusions that extend beyond the descriptive data alone. You can test hypotheses about your sample population. Inferential statistics are techniques that allow us to use samples to make generalizations about the populations from which the samples were drawn. Inferential statistics allow us to test hypotheses. Two questions that arise about any hypothesized relationship in a quantitative study are: does a relationship exist? Can the null hypothesis be rejected? What is the likelihood or probability that the relationship is due to chance? There are many different statistical methods used to test hypotheses. Chi-square, t-test, and ANOVA are common bivariate statistical tests that measure the variation or differences between two variables. Regression analysis is a common multivariate statistical test that simultaneously measures the relationship of several independent variables with a dependent variable. The p-value evaluates how well the sample data supports the argument that your null hypothesis is actually correct. Null hypothesis, a statistical hypothesis that suggests there is no effect, relationship, or difference between groups, participants, or quantities in a research study, whereas the research null suggests there is a relationship. If the p-value is less than 0.05, then you can reject the null hypothesis with confidence. In other words, p less than 0.05 suggests that there is less than a 5% chance that the statistical finding reported would have occurred if the null hypothesis was true. Common statistical tests to determine the strength of a relationship include correlational analysis, which examines the strength of a relationship between two variables, multiple regression analysis, which examines the relationship between a dependent variable and one or more independent variables. Two variables are positively associated when larger values of one tend to be accompanied by larger values of the other. For example, as study time increases, your grade may also increase. Or based on the picture to the far right, as auto accidents increase, auto insurance also increases. The variables are negatively associated when larger values of one tend to be accompanied by smaller values of the other. For example, as class absences increase, your grades may decrease. Or based on the picture to the far left, as auto mileage increases, auto value decreases. Notice the graph in the middle represents no correlation between variables. Correlation coefficient. Correlation analysis produce correlation coefficients which produce or provide a measure of the strength and direction of the correlation varying from -1 to +1. Positive values indicate that the two variables are positively correlated. Negative values indicate that the two variables are negatively correlated. Values close to +1 or -1 reveal the two variables are highly related. As previously described, the p-value tells you if the correlations are statistically significant. Class exercise. Which of the following correlations indicates the weakest relationship? Is it positive or negative? The strongest relationship? Positive or negative? If we compare A, B, C, and D, A has the weakest relationship and it is positively correlated. B has the strongest relationship and it is also positively correlated. Statistical significance. Within quantitative research, relationships between variables can be significant without being meaningful. Effect size is a way of showing the strength or magnitude of association between variables. Effect sizes complement inferential statistics such as p-values. An effect size of D is equal to 1.0 for a reading program means that the reading program increased the reading score of the average student to 1 standard deviation above the mean. A negative effect size of D is equal to -1 means that the reading score of the average student in the program decreased by 1 standard deviation below the mean. Generally, an effect size of zero point 0.2 is considered small, zero point 0.5 moderate, and zero point 0.8 large.